if you go over 1 and up 0.7, okay? Over 1 and up 0.7, or up 1 and over 0.7. And the distance between those 2 points is going to be 0.5 root 2.
Yeah.
Over 1, up 0.7, or up 1 over 0.7. This distance is 0.5 root 2. This distance here is also 0.5 root 2. So I've drawn a dodecagon. And then at this next section, these are all 2 times 0.5 root 2. And then here it's 3 times 0.5 root 2, 4 times, and so on. So that just keeps getting bigger and bigger. And I'm going to show you this. So this is basically both of those 2 charts put on top of each other. You have all the square root radius circles. Then we have these degree lines going out here on top of the XY coordinate plane. So now we've got all the ingredients that we need. There's the 45 degree. We use that for the numeral 2 and the numeral 6. So now we're going to use this line right here, again with the rise over run of 1 and then over 0.7, and we're going to use that for the numeral that represents the number 3. So here we go. So that particular circle doesn't intersect the grid on any lattice points. Here's the 3 right here. Doesn't hit any points, but we are going to start right there. That's the 3rd circle, 1, 2, 3 with the radius square root of 3. I'm just going to draw a line from there. I'm going to trace this to this point right here. So I'm going to write down the coordinates for that spot. It's over 1.9. The x is 1.9 and the y is 1, 2, 3. So right away we have a 3. And also just to note, from this lattice point right there going over this way, 0.9 plus 0.3 equals 2. That's that point there. So there's a 0.3 gap, similar to how with the numeral that represented number 6, there was a 0.6 decimal happening. But here we can also just go right across here, 1, 2, 3, and this is minus 1.3 and 3. So the length of that line is 3. So there we have the value of the number incorporated in the design of the numeral. And you can see that's kind of, this shape we got here is almost like the number 2 turned upside down. You know, you got that same, you know, the baseline, then the angle going to the curve. And now I'm just going to trace again this circle. And I'm going to stop it right there on the same, I'm going to say 30 degree line, although it's not quite. And the reason I'm saying it's not quite is if you start to figure out the dimensions there, it doesn't work out to square root of 3, 1, square root of 4, just for you people who are paying attention. So this point here, like the numeral for the 6, I just went outside of that circle a little bit and had the, there it was the 1.9 and minus 1.9 for those coordinates, root 2. But here we're off a little bit. So if there is a point just outside that is part of this line, because this line also can go over 0.1 and up 0.07. You could really go very small increments of going over 1. So doing that up here, you get the point A6 and 1.6. So remember, we're counting in duodecimal, so it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and then the 10. So that's what this is, point A6 and then 1.6. So you sort of go over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, and then a half. And then you go up, and that's where we are. That's where we are up there for that point. And then go up. So things to note, kind of interesting. 2 root 3 in duodecimal equals the square root of 10. Nice and simple somehow. That works out in base. This is like a duodecimal thing. Okay, so we can figure out the length from the center to there. This spot is exactly halfway. So we have like half kind of empty space and half full space. But this is bigger than 2 root 3. We can figure that out by, well, you know what? I'm going to let you figure that out because we've got a lot of video already. I didn't want to get too much into the math. I just want to show you why the numeral 3 looks the way it does and give you a little bit more information. So that's that point, that point, that point there. We got the 0.3 in the corner there. If you want to see a good example of this particular numeral, you can look on the barcodes of things. Not all of them, but some do use this flat top numeral 3 and the 5. Also, you can see good examples of some of these numerals in their kind of geometric form. All right, so I hope you enjoyed this video, and now we've got this new angle. We're going to keep using that in the rest of the numerals. So the next one's going to be the numeral that represents the number 4. Thanks for watching. Hope you can join me for that next one. Bye for now.